Hey guys, so in my previous video I discussed example 5.11 of SC Gupta, this book, Fundamental Statistics of SC Gupta, and now in this video I'm going to discuss example 5.13. I skipped example 5.12 because I thought that all of the concepts that it was covering were already covered earlier in example 5.11. So let's just move with example 5.13. Right. Right. So this is example 5.13 SC Gupta. Right. So this question says that show that for a symmetrical show that for a symmetrical, sorry for my handwriting, I'm just new to this pad. For a symmetrical distribution, show that for a symmetrical distribution fx is equal to 2a upon pi into 1 upon a square plus x square, where x lies between minus a and a. Show that for a symmetrical distribution, this where x lies between minus a and a, the second moment with respect to the mean, or the variance, or ex square minus the whole square of ex is equal to a square. We need to show this 4 minus pi. This is the symmetrical distribution, and we need to show this. Show that the variance, or the second moment with respect to the mean, is equal to a square into 4 minus pi upon pi. Let me just adjust the weight. This seems to be fine, right? And the third and the fourth moment with respect to the mean is equal to a to the power 4 into 1 minus 8 upon 3 pi. We need to show this. So we have been given the symmetrical distribution, and we need to show this, that the second moment with respect to the mean is equal to this, and the fourth moment with respect to the mean is equal to this. Now let's just first check if this PDF is a valid PDF. It's a good practice, right? We don't need to, we can jump straight into it, but it's a good practice to just check if it's a valid PDF or not. And for checking a valid PDF, we know that the integral of fx dx over the limits given to us should be equal to 1, right? So we are given that fx is 2a upon pi into 1 upon a square plus x square dx, where this lies between minus a and a. This is equal to 1, right? I'm just dividing this whole page into two parts. Yeah. So this becomes 2a upon pi, can come out because this is a constant term, minus a 2a, 1 upon a square plus x square dx. We need to show this. Let me just remove this one here. we need to show that this is equal to 1, right? Now where is my pen? Yes. So now I need to apply a property here. We know that the integral of 1 plus b square dv, any number, any alphabet, b square dv is equal to tan inverse v plus c. This is the constant of integration because I didn't put the limits, right? We know this is a property. I'm just writing this so that you don't get confused. Now I have to create v, or only just a constant term here, and I need 1 here. So I can take out a square common. This becomes 2a upon pi, and a square comes out common. This becomes minus a 2a. This is the limit, and this is the a square that I just took common from the denominator. This becomes 1 upon x upon a whole square dx, right? Now let x upon a, simple substitution, is equal to v. This becomes dx is equal to a dv. I just took a to the RHS. Dx is equal to a dv. So I'll replace dx with a dv and x upon a with v. Now when x goes to a, because the limit is a, the upper limit, when x goes to a, the upper limit, v, which is x upon a, goes to 1, a upon a, this goes to 1. When x goes to minus a, v, which is x upon a, goes to minus 1. So minus a upon a becomes minus 1. So this goes to minus 1, right? Wait a second. Sometimes what happens is that my recording gets stopped in between on its own. Yeah. So my new limits are for v. My limits are v goes from 1 to from minus 1 to 1. So this becomes 2a upon pi, 1 upon a square, minus 1 to 1, 1 upon 1 plus v square, and replacing dx with a dv, right? So a is a constant, I can take it out, and this is an a square, so this becomes 2a upon pi into a upon a square. Let me just go to the next page. So I'll just draw a line. Right. So this becomes 2a upon pi into 1 upon a square, and I took out a common, so this becomes minus 1 to 1, 1 plus v square, 1 upon 1 plus v square dv. So I can just cancel this and this. This becomes 2 upon pi. Now this is tan inverse v. I showed you in the previous slide this property, right? So this becomes tan inverse v, 2 upon pi tan inverse v minus 1 to 1. These are my limits. So this becomes 2 upon pi tan inverse 1 minus tan inverse minus 1. Let me just write this again. So this becomes 2 upon pi tan inverse 1 minus tan inverse minus 1, right? So this becomes 2 upon pi into 2 tan inverse 1. So this is 4 upon pi into tan inverse 1. Now how did I write tan inverse 1 minus tan inverse minus 1 as 2 tan inverse 1? This is a property where tan inverse b is any number, tan inverse minus b is equal to minus tan inverse b. We can write this like this, where b belongs to any real number or it's any alphabet. This is just a property, so just remember this. Right, so I shouldn't be writing this b belongs to r. B can be anything, whether it's an variable or a number. This holds true. This is just a property. Right, so now this is 4 upon pi tan inverse 1. Now we know that tan pi by 4 is equal to 1. This implies that tan inverse 1 is equal to pi by 4. Therefore 4 upon pi into pi by 4, cancelling all of this gives me 1. So my integral of fx dx with my limits minus a to a gives me 1. This means that this is a valid PDF, and we can proceed. Let me just check if my recording is still going on. Yes, it's going on. Right, so now moving forward, I need to find the value of the variance or the second moment with respect to the mean. So for this, I first need to find the second moment with respect to the origin minus the square of the first moment with respect to the origin or the mean. This is ex whole square, or the square of the mean, and this is ex square. So first I'll be finding this, which is ex square, or let me just for more clarity I'll be writing this like the second moment with respect to the origin, or ex minus 0 whole square, which is equal to ex square, which is x square. Now fx dx, my fx was 2a upon pi into 1 upon a square plus x square dx, right, minus a to a. So 2a upon pi is a constant term, I'll take this out, so this becomes 2a upon pi this no wait, yeah, so this step I'm doing this here. Yes, so mu 2 dash becomes 2a upon pi minus a to a. Now what I can do is I'll add a square in the denominator and I'll subtract a square in the denominator. I'll add a square in the numerator and I'll subtract a square in the numerator. Adding and subtracting a square from the numerator, and my denominator is just same. Now separating this gives me 2a upon pi. I'm just separating the integrals. Minus a to a. Now x square plus a square upon a square plus x square, this becomes 1. So 1 minus a square upon a square plus x square dx minus a to a. Right, so this gives me this term. So 2a upon pi x minus a to a, 1 dx is x, integral of this this is equal to x, and subtracting now now I'll just take out a square outside because it's a constant term. Now minus a to a, again a square plus x square dx. We just solved this integral earlier, so I'll just take out a square outside and I'll be left with 1 plus x upon a whole square, and I'll be substituting x upon a equal to v. I'll be showing you all the steps. Right, so this was equal to this first term was equal to this. Right, I'm just drawing this arrow so that you can understand. This was equal to x minus a to a. This came from here. Solving this integral gave me this x minus a to a. Now moving forward, I have 2a upon pi x minus a2. I'm not putting in the limits just now. I'll be solving the other integral, then I'll be putting in the limits. Now from the denominator I just took out a square common. This gives me dx minus a to a. Now x upon a is equal to v, dx is equal to a dv, right? Dx is equal to a dv. Replacing dx with a dv, a comes out common, so this gives me ultimately, I'm just 2a upon pi x minus a to a minus a square and a square gets cancelled. This gives me 1 plus v square dv, a dv, right? So replacing dx with a dv, so minus 1 to 1, right? So when x goes to a, v goes to 1. When x goes to minus a, v goes to minus 1, right? So minus 1 to 1. The lower limit is minus 1 and the upper limit is 1. Let me just check if my recording is still going on. Yes, it's going on. 2a upon pi x minus a to a. This becomes a tan inverse v, where my tan inverse v, a is the constant term, so I just took it out common, minus 1 to 1, right? And this becomes tan inverse 1 minus tan inverse minus 1, and this is equal to tan inverse 1 plus tan inverse 1. This becomes 2 tan inverse 1. Now 2 tan inverse 1 is 2 pi by 4, right? So what we have here is 2 pi by 4, and this is a minus of minus a, right? And this is a into 2 pi by 4, right? And this is 2a upon pi, multiplying this whole. This gives me 2a upon pi into 2a minus 2a pi by 4. This gives me, just taking out 2a common and pi in the denominator, this gives me 1 minus pi by 4, right? So this becomes 4a square upon pi into 4 minus pi upon 4 and 4 gets cancelled, so I'm left with a square pi into 4 minus pi. So my second moment with respect to the origin, is a square into 4 minus pi upon pi. Now wait a minute, isn't this the value of mu2 with respect to the mean or the variance? Let me just show you. When I was solving this example, I had to prove that this with respect to the mean, my second moment with respect to the mean is coming out to be equal to a square into 4 minus pi upon pi. But when I tried to find this out, this is mu to this, the second moment with respect to the origin, this is coming out to be equal to this. That means that this might be equal to 0. Only then we have solved this correctly, otherwise I've made some mistake. So this should be equal to 0, right? So but is this true? I need to check, I need to go back. Let me just erase all of this. This was just for you to understand, right? So if just remember this value, a square into 4 minus pi upon pi a square into 4 minus pi upon pi, right? So when I just go down, I find this expression, and these two expressions are equal, right? So these two expressions are equal, right? So now what I can do is I just need to find the first moment with respect to the mean, and this should be coming out to be equal to 0, only then I've solved this correctly. So solving this from minus a to a, and x, this is ex, so multiplying x, fx dx, this gives me minus a to a x into fx is a square plus x square into 2a upon pi. I'm just taking this out because this is a constant term, right? So this becomes, right, now how do I solve this integral? I'll be taking a square plus x square, I'll be assuming it to be t, right? So this becomes 2x dx is equal to dt. Now x dx, I have that in the numerator, so I can write this as dt upon 2, right? So this gives me minus a to a minus a to a minus a to a 1 upon t. Now replacing x dx with dt upon 2, right? Now I need to change my limits also. I need to change the limits also. So this is 2a upon pi outside, this is a constant term. Now when x goes to a, t, which is x square plus a square, becomes 2a square, right? So a square plus a square becomes 2a square. When x goes to minus a, t, which is equal to x square plus a square, becomes minus a whole square plus a square, which is equal to 2a square again. So my upper limit and my lower limit are equal, which means my my first moment with respect to the origin is 2a upon pi 2a square into 1 upon t dt by 2. I can write this as 2a upon pi into 1 upon 2 2a square to 2a square dt by t. Now when my lower limit and my upper limit, both of these are equal, I don't have any area that I can integrate over. This means that this is equal to 0, right? What is integration? Integration is just the area under the curve. So when my lower limit and my upper limit both are equal, I cannot find any area. There's no area that I can find. So this gives me 0 area. This is just a point. So this is equal to 0. Hence my mu2 with respect to the mean is equal to, with respect to the origin, my second moment with respect to the origin minus my first moment with respect to the origin and the square of that, and this is equal to 0. This implies that my second moment with respect to the mean or the variance is equal to the second moment with respect to the origin, and I just found out the value of this earlier here, right? So this is a square into 4 minus pi upon pi, a square into 4 minus pi upon pi, a square into 4 minus pi upon pi, right? And this was what we had to show. Right? So is this the same value that we had to show? Let me just check. A square into 4 minus pi upon pi, a square into 4 minus pi upon pi, a square into 4 minus pi upon pi, right? Let's just move now. So moving to the next slide, I have a square into 4 minus pi upon pi. Yeah, so now I need to find this. the fourth moment with respect to the mean. So actually there's a very large formula that I discussed in the last class. I don't remember that, it's too large for me to remember. I'll be just looking the formula from the book, and the formula is the fourth moment with respect to the mean is equal to the fourth moment with respect to the origin minus 4 times the third moment with respect to the origin into the first moment with respect to the origin minus 6 times. I'm just trying to recall the formula. Is this the formula? Let me just check. The fourth moment with respect to the origin minus 4 times the third moment with respect to the origin into the first moment with respect to the origin plus 6 times the second moment with respect to the origin with the product of the first moment with respect to the origin, the square of that, minus 3 times the first moment with respect to the origin to the power 4. Now we know that the first moment with respect to the origin is equal to 0. So this term automatically, the fourth moment with respect to the mean, gets reduced to this, because all of this is 0. This is 0, this is 0, and this is also 0, right? So we just need to find this, the fourth moment with respect to the origin, or ex minus 0 to the power 4, or ex to the power 4, right? Let me just draw another bracket so that you don't get confused here, right? So this is that. So this is x to the power 4 fx dx minus a to a, right? So let me just move to the next slide, it will be clearer. So this is 2a upon pi minus a to a 1 upon a square plus x square product with x to the power 4 dx. So fx 2a upon pi comes out because it's a constant term into x to the power 4 dx. We need to find this. Now for solving this integral, what I can do is 2a upon pi, let me just wait, this is minus a to a. Now what I can do is I can subtract a to the power 4 and add a to the power 4 in the numerator. So x to the power 4 plus a to the power 4 minus a to the power 4 upon a square plus x square dx. This gives me 2a upon pi minus a to a, and now separating the integrals, so just writing this here again, 2a upon pi minus a to a x to the power 4 minus a to the power 4 upon x square plus a square minus a plus a to the power 4 upon a square plus x square dx, and my limits are minus a to a, right? Now this x to the power 4 minus a to the power 4, I can just apply my identity of a square minus b square. A square minus b square is equal to a minus b into a plus b. So I can just apply this identity here. This becomes a x square plus a square into x square minus a square, right? Because of the identity a square minus b square is equal to a plus b into a minus b, right? And x to the power 4 is x square, the whole square of x square, right? So just applying that identity here. Moving on, what I'm left with is 2a upon pi minus a to a x square plus a square into x square minus a square upon x square plus a square dx plus a to the power 4, just taking this out common, minus a to a 1 upon x square plus a square dx, again the tan inverse v. That is what I'm going to use. So this gets cancelled, right? So I'm left with the x square minus a square 2a upon pi. So integral of minus a to a x square plus a square dx and this becomes a to the power 4. Now just taking out a square common, substituting x upon a as v. Now x goes to a, v goes to 1, x goes to minus a, v goes to minus 1, right? V goes to minus 1, and dx is equal to a dv. So I have another a here in the numerator, just taking out that common, and what I'm left with is minus 1 to 1, 1 upon 1 plus v square dv. Now I'll be just integrating this. So x square, the integral of x square becomes x3 upon 3, x to the power 3 upon 3 plus a square. A square is a constant term, so I'll be left with a square x minus a to a. I have 2a upon pi here. I'm not putting the limits just now, I'm waiting. So I'll be just cancelling this, left with a cube in the numerator, a cube tan inverse v minus 1 to 1, and just putting another bracket here, minus 1 to 1. I hope you guys are getting it. I just just skipped some of the steps, just tried to explain all of this. This is the second integral that I solved, just substituted it like I did in the previous steps. So 2a upon pi, and this becomes, now putting in a cube upon 3, a cube upon 3 plus a cube, wait, this is minus, wait, I made a error here. I need to, this was minus because x plus a square has been cancelled and we were left with x square, we were left with this term only. So this is x square minus a square. Again I need to use my eraser here. So yeah, so this is cube minus, right? So this becomes a square into a after substituting. Now another minus sign here, minus, now substituting minus a, so this becomes minus a whole cube upon 3 minus a square into minus a, right? And this is a cube, now substituting limits here, so this becomes 2 tan inverse 1. Why? This was tan inverse 1 minus tan inverse minus 1, so this became 2 tan inverse 1, right? This was tan inverse 1 minus tan inverse minus 1, which becomes 2 tan inverse 1 because of the property that tan inverse minus x is equal to minus tan inverse x, right? Using this property, right? So I hope you guys are getting it. So this becomes 2a upon pi. Now after substituting, this became a cube upon 3, and this was minus a cube minus, I'm just opening the brackets. This becomes minus a cube upon 3 plus a cube, so minus minus plus, and this is plus a cube and another minus sign, so this becomes minus a cube. So this is minus a cube plus a cube by 3 and minus a cube, and this is the other term that I had was plus a cube to tan inverse 1, right? Let me just show you guys, right? So this was plus a cube to tan inverse 1, plus a cube to tan inverse 1. So the value of my fourth moment with respect to the mean was equal to the value of my fourth moment with respect to the origin, because all of my terms containing mu, the first moment with respect to the origin was 0, all of my because this is 0, right? So just solving this becomes 2a upon pi, and 2 tan inverse 1 is equal to tan inverse 1 is equal to pi by 4. So I'll be just substituting it. So this gives me 2a cube upon 3 minus 2a cube plus 2a cube into pi by 4, right? So this becomes, I'm just taking out 2a common, 2a cube common, 2a cube common. So this is 2a cube common upon pi into 1 upon 3 minus 1 plus pi by 4. So 4 and 3, this becomes 12. So I'm left with 4a4. This is a cube and this is 1 another power. So this becomes 4a to the power 4, 4a to the power 4 upon pi, and 1 by 3 minus 1 becomes minus 2 by 3. So pi by 4 minus 2 by 3, and this gives me ultimately so just raise this. So this becomes 3 pi minus 8, 4 into 8. I'm just taking the LCM. So this gives me, cancelling 4 and 12, I'll be left with 3 in the denominator. So this becomes a to the power 4 into 3 pi minus 8 upon this pi and this 3. This gives me 3 pi. So I can just separate this out. This gives me a to the power 4 into 1 minus 8 upon 3 pi. Let me go to the next slide. So our final answer is the fourth moment with respect to the fourth moment with respect to the mean, which is equal to the fourth moment with respect to the origin, is equal to a to the power 4 1 minus 8 upon 3 pi, right? Let me just check if this is the right answer. Let me just check. Let me just go to my question. 32. Yes, so 8 to the power 4 into 1 minus 8 upon 3 pi. 8 to the power 4 into 1 minus 8 to the power 4 into 1 minus 8 upon 3 pi. 8 to the power 4 into 1 minus 8 upon 3 pi. This is our final answer, and we have shown that this is also correct, and this was also correct. Wait, this was also correct, right? So showed that, and this was our example 5.13 of SC Gupta. I hope you guys like it. If you like it, if you like the video, just put a comment down and subscribe the channel. And also, if you have any tips or anything that I did wrong, please write in the comments so that I can look up and fix my errors. Thank you so much. I hope to see you in the next video.